Welcome to lesson 7138, Sums and Differences of Sinusoids. Okay, so remember, when looking at graphs, A changes the amplitude, B changes the number of waves, per period. If B is bigger than 1, you get more waves per period. If B is in between 0, I'll put this on the wrong side. B has to be bigger than 0 and 1. You get less waves per period. Sometimes we'll call it C, but they keep referring to H and K. So this is minus. If it's X minus H, it's a right shift. X plus H is a left shift. And then finally for K, if it's plus K, it goes up. If it's minus K, the graph goes down. Okay, you can read through all of this. We're going to graph these in the calculator anyway, so you'll see the effects. Okay, determine whether each of the following functions is or is not a sinusoid, which means it oscillates at roughly the same height and the same distance between each wave. Okay. Okay, so A, let's put A in blue because that's how it's going to show up on the calculator. A is blue. You're going to put this in the calculator. You're going to change your window to negative 2 pi for X min. X max is going to be 2 pi. Your X scale, that's the tick marks on the X axis, is going to be pi over 2. Your Y min is going to be 10, and your Y max win is negative 10. Your Y max is positive 10. And you're going to see this graph. All right, so you get close to the x-axis. It goes down, it goes up, it goes up, it comes down, it comes up. So it's going to look something like that. So yes, this is periodic. Okay, looking at B, same window. B is red on your calculator. And this graph looks pretty interesting. So, and negative 2 pi is here. It bounces up, it goes below, it goes higher, it goes lower. All right, so that looks a little weird. So we're going to say no. And if you pay attention, they have different periods. But the periods do not match. So 2 pi divided by 5 for the cosine and 2 pi divided by 3 for the sine, not the same. They're not equal, so the periods don't match. It's not periodic. On your calculator, C will be black. But again, 3x two pi divided by 3. The cosine has a period of 2 pi over 3, the first cosine. The second one, 2 pi divided by 2 equals pi. 2 pi and 2 pi over 3 are not equal to each other, so this will not be periodic. So your black graph, because you can graph all of them, y1, y2, y3. is, looks like this. Does look periodic for a while. Then it kind of gets low, and then it goes back to this. And then they get short again. So it does look periodic for a while, but then it jumps off. Okay, finally for D, they all have the same period. 2 pi divided by 3/7 gives us 2 pi divided over 1 divided by 3/7, which means 2 pi over 1 times 7/3 is 14 pi over 3. Since they all have the same period, they're all going to match up. So this will be sinusoidal. Okay, so let's look at A here. Find the period of F. So there's no B term. Well, there is a B term, and we had to understand that B equals 1. So 2 pi divided by 1 equals 2 pi. So that's our period. Okay, so now for B, estimate the amplitude. Okay, so what we're going to do is come back, graph this thing, and then hit, once your graph is up, you're looking at your graph, hit second. We did this before, trace. Trace is in the top menu. It's in between zoom and graph. All right, arrow down to maximum. You're going to hit enter for left bound, hit enter. Right arrow to the other side of the top, hit enter, and then hit guess, hit enter again. So when X is 0.3805, Y is 5.385. So let's say call it 5.39. Let's call this 0.38. So this is the maximum. 5.39 is the maximum. And we want the phase shift graphically. And so now to get the phase shift, we're looking for a 0. Okay, so that was to get the amplitude. All right, so now for phase shift, do the second thing again. Do second, do trace. All right, so this time we're looking for a 0. So we go down to 0, where it says 0. Click that, touch 3, hit the arrow down, hit enter. And then, again, you got to go below the x-axis as your left bound, hit enter. Right arrow above your x-axis for right bound, hit enter again. And the 0 is going to occur when x equals 1.1919 and y equals 0. So it goes, the shift is left, so it's plus. So it's x plus 1.19. Okay, so now we got our shift, we got our amplitude. So this starts at 0 and goes up. So we're going to say 5.39 sine x plus 1.19. So this would approximate our sinusoid using the calculator. This is equivalent to this function, or similar. Okay, show that sine 2x plus cosine 3x is periodic but not a sinusoid. All right, so let's look at this example here. We know that the b's are the same, so 2 pi divided by 2 is equal to pi, and 2 pi divided by 3 are not equal to one another. So because the periods aren't the same, these are not sinusoids. So if we were to graph this, negative 2 pi to 2 pi, we would see something like this. So it looks periodic where you have ups and downs. You got the same maximum, the same minimums, but it doesn't do it each time.